Alright, in this video we're going to talk about all the types of vectors, okay? The important one, the selected one, okay? The first one I'm going to talk about equal vectors, okay? What is meant by equal vectors? Two vectors are equals if they have the same magnitude and the direction. Let's say vector A is equals to vector B. Then we said that vector A and vector B has same magnitude, right? Same magnitude and same direction. This is the key point here. So they have same magnitude and they have same direction. So for three-dimension case, let's say vector A is x1 I plus with y1 j plus with z1 k, and vector B, let's say I have x2i plus with y2j plus with z2k. We said that vector A and vector B are the same. Means that the first thing is the magnitude are the same. Alright, the magnitude are the same. So means that the magnitude of vector A and vector B are the same, and the scalar multiple will be 1. Alright, 1. And they have the same direction, okay? They have the same direction. Or I can say that x1 is the same as x2. X1 is the same as x2, and y1 is the same as y2, and z1 is the same as z2. This is very important. First, if they say that they are equal vectors, means that the two vectors, okay, the two vectors having the same direction, same length, same magnitude, then we say that this two vector is a equal vectors. Alright, let's solve some equation, solve some problem about equal vectors. Alright, now let's say if I telling you that these two vectors, these pairs of vectors are equal, means that these two vectors are equal. How are we going to solve to find the value of alpha, beta and gamma, right? So I just go through this so that simple, so that you understand. So these two vectors are equal. We say that if the question said these two vectors are equal vectors, so then I can compare directly. The alpha minus 1 is the same as negative beta. This is the thing that you must do. The value here must be the same, right? Because A is the same as B. And the scalar here is 1, right? So, and I can forming the equation, I'm getting alpha plus beta to be 1, right? Equation 1. We can relate this way. So, and J, right? The coefficient for J will be the same when the two vectors are equal. You have to understand about this. So means that alpha minus beta, right? Alpha, I bring the beta, go over that side, and 2 plus 1, we have 3 as equation 2, right? So with these two equations is enough for me to solve the value of alpha and beta. So of course the gamma, right? The coefficient for k here, for this vector, and will be the same also. Means that the gamma is the same as the 2 gamma here, right? To solving this, we can solving 2 gamma minus with gamma equals to 0, right? So 2 gamma minus gamma will be gamma equals to 0. So the value of gamma must be 0, because if these two is the same, right? Definitely there must be 0, right? 0, so that they are the same, right? You see gamma, 1 is 2 gamma, so this must be 0, alright? So now you know that gamma is 0. So how to solving this? Very simple. You just solve simultaneous equation, right? You're just taking 1 plus with equation 2, then alpha plus alpha, you have 2 alpha, beta plus with negative beta, you have 0, 1 plus 3, you have 4. So then you have alpha to be 2, right? If alpha is 2, you can substitute into 1 and finding the beta. So beta is 1 minus with 2, which gives you negative 1, right? Negative 1. So then these two vectors will be the same, right? If you substitute the value here, you see, if you substitute 2, alpha 2, 2 minus 1 is 1, right? 1i. And you substitute beta, negative 1 and negative 1, right? 1 and 1, right? The x component is the same. So if you look at the beta here, the value of beta is negative 1. Negative 1 plus 2 is 1, right? Alpha, 2 minus 1 is 1 also, 1i, 1j, right? So, and this one is 0k, 0k, right? Gamma. So means that A and B is 1i plus 1j, B is also 1i plus 1j, which is the equal vectors. Alright, so you only can do this way when you know that these two vectors are equal, right? This is the meaning of equal vector. Alright, let's discuss about another types of vectors.